Hi guys, in today's video I'm going to be continuing with the AP Calculus BC syllabus. I'm going to be discussing the second derivative test. So the second derivative states that, let f be a function such that f prime of c, so f prime of c is the derivative of f at a point c. So if the derivative of f at c is 0, and if f double prime of c exists, so if f prime of c is 0 and f double prime of c exists, if so there are three cases. So if f double prime of c is greater than 0, then f has a relative minimum at c comma f of c. So when f prime of c is equal to 0, f double prime of c exists, and f double prime of c is greater than 0, then the function f has a relative minimum at c comma f of c. So now the second case is that if f double prime of c is less than 0, then f has a relative max or relative maximum at c comma f of c. So if f double prime of c is less than 0, then f has a relative maximum at c comma f of c. Now finally, the third case is when f double prime of c is equal to 0. Then no conclusion can be reached. So these are the three conditions for the second derivative test. So now let's look at an example. So if f of x, so this example, it makes use of the second derivative test to solve it. So if f of x is equal to 4x cubed minus 3x to the power of 4, find all critical points. Find all critical points and classify them and classify the critical points using the second derivative test. So this is our question. So for this question, we can use the first derivative test where we differentiate it and then see how the slope changes. But as you can see, it's still asking us this question to do the second derivative. So I want you all to pause the video for 1 second. Try to figure out how this can be done. So I hope you all were able to solve it or do it. So now let's look at how to solve it. So we know that it says that f prime of c has to be equal to 0, right? So let's find f prime of x. That is 12x squared minus 12x cubed. So this is the derivative of f of x, right? So now we know that for a critical point, the first derivative is equal to 0. So now let's find the values of x, which gives us this, the left-hand side is equal to the right-hand side. So x is 0 and x is 1. So these are the points at which 12x squared minus 12x cubed is equal to 0. So now let's find the corresponding y values. So 0, 0 and 1, 1. So we're just substituting 0 in f of x and 1 in f of x as well to find the y values. So now let's look at the second derivative. Let's find it. That is 24x minus 36x squared. So now what we do is we plug in the critical points. So first let's plug in 1. So f double prime of 1 is equal to 24 into 1 minus 36. So that is negative 12. So thus, what can we conclude with this? So at 1, we know f prime of x is, so f prime of 1 is 0, and f double prime of 1 is negative 12, which is less than 0. Thus, we can conclude that there is a relative maximum at 1, 1, because f prime of 1 is equal to 0 and f double prime of 1 is less than 0 because it's negative 12. So thus there is a relative maximum at that point. So now let's find f double prime of 0. F double prime of 0. So if we substitute it in f double prime of x, we get 24 into 0 minus 36 into 0, which is just 0. And remember what it was. So when f prime of 0, when f prime of c was equal to 0, and when f double prime of c was also equal to 0, remember that we said that there was no conclusion which can be reached. So there is no conclusion. There is no conclusion. So that is our final answer. So we found the two critical points and classified them as a relative maximum and that there is no conclusion. Okay, that's it for today's video, guys. In today's video, I discussed the second derivative test and also discussed the question with it. Thank you.